Okay, so let's move on to look at the different IDEs we have talked about, like Visual Studio Code, Spider, PyCharm, and PyDev. These are some famous IDEs that are available in the market today. We will look at a couple of them as part of this lab. We have Visual Studio Code. If you are coming from C# world, .NET programming world, where you are comfortable with Visual Studio, I think Visual Studio Code is again an open source. It's very lightweight. Many of the larger organizations have adopted Visual Studio Code as their default developer platform, not only for Python, but also for many other languages that you can code with Visual Studio Code. So I'll briefly show you that. So this is what is the Visual Studio Code is, where you can create sample.py. Is just I just created a new file where I can say the same commands that we've been using. I say hello world from Visual Studio. Let's say just to test how it works, and say print. The beautiful thing about this is that you keep getting this tooltip, which shows you the parameters, the function, the methods that are available. So you don't need to remember all of them. It's available on the fly, on the runtime. So that's the beauty of this. Then once you created that sample.py, and then you can save it. Then you run it. Of course, you see that output at the bottom where it says hello world from Visual Studio, and then it added the two variables that we created, a plus b. Another nice thing about the Visual Studio Code is that you can do lots of debugging and investigation when you are writing large amount of number of lines of code where you don't know where the problem is. So it allows you to do all sorts of debugging and investigation that you can do to fix your bugs. And you can also have a full end-to-end environment where you have multiple .py files you create for Python in all the objects. And when you have the dependencies on calling each other in a very large project setting, Visual Studio Code works fantastic in that scenario. So now let's take a look at another one, which is the Spider. Spider is another IDE which is very popular. It is similar to what we have seen in Visual Studio Code. It also provides you an opportunity where you can place where you can create a .py file. Here we can say the similar thing. You could save it, then you can run it. So you get hello world from Spider here. You also have the interactive command shell here, where you can directly do the way we have done from the terminal window just recently, where we have shown how you can directly work with Python. You can do that as well from Spider. So you have multiple ways of using Python. You can directly work on your terminal or command prompt, or you could use Visual Studio for code, or you could use Spider, or we could create Python code in any of the notebooks and then call Python executable. It depends on your preference, your comfort level. If you're coming from Java world, you can use PyCharm. If you're coming from .NET world, you can use Visual Studio Code. And we will also look at Jupyter Notebook, which is the most popular when it comes to doing data science and data engineering, where it allows you to do interactive commands that you can give to the engine and which produces the output. It allows you to go back and forth, and so very advanced notebooks, and all the cloud providers such as Azure, Google, and Amazon, they all provide their notebooks on the cloud. It is free to use, and that's what we will be using in this course. So let's go through some of the basic steps on how you can leverage a Jupyter Notebook to create machine learning data science experiments. So it allows you to combine text. You can put any markdown text that you would want to add to your program to maybe explain or giving some titles and paragraphs about what you are trying to do. You could also have HTML and images that goes with the notebook, and we can also generate visualizations, because any of this data science machine learning experiments will not be complete without any visualizations. And of course that you could use that Python code which is runnable. This is not an IDE. It's mostly used for exploratory data analysis. You can also showcase your code very easily with that. The example is something like this. So where you have the cell for each one of these commands that you would be sending, where you could have this visualization attached that explains your data, it explains your analysis. Basically, you will be installing that from jupyter.org. If you have installed Anaconda, it is already installed for you. You don't need to separately install it. You can directly launch it from the Anaconda, or you can launch it from your command shell terminal window, where you can say Jupyter space notebook. It launches your Jupyter notebooks actually. So you just say Jupyter space notebook, it will launch it for you. And the easiest way to do it is to directly launch it from the Anaconda installation. So once you launch, based on where you launch from your command shell, it will open up the file directories where you have your notebooks that you can create and save and work on in different folders. So you have the access to traverse around the folders and then be able to create notebooks in anywhere you would like, and then call them back again, then be able to continue to execute. So let's do a small lab. We have this starting jupyter.md file from the file that folders that you have downloaded from the Git. It's in the notebook folder. I'll show that. So for some reason, if you do not have your Jupyter not starting, or you are running into some problems, I would ask you to install Jupyter again manually. It's kind of a repair that you can do to for all the installation that you've already done. You can install using pip install Jupyter, and then you can start it Jupyter Notebook. And if for some reason it is not starting up, even after you start it and you see this text that shows that it has started, but you are not able to see that in the browser, where you can go to your browser, you can type in HTTP, your IP address, or it's a local host, in your case that you are running it from your desktop or a laptop. And the Jupyter Notebook is by default using the port 8888. So you can manually type it and run it again. Or instances where you started your Jupyter notebook and then accidentally you close it and you don't know how to get back. The best way to do it is that go to the browser and then type in HTTP localhost colon 8888. Automatically it will show your Jupyter instance that you already have. So basically this is what you would see, localhost and colon 8888 is what you will see here. Okay, so the next one is that we will do a hello Jupyter IPYNB. IPYNB stand for Iron Python Notebook. So all of the Jupyter notebook will have that extension IPYNB. Iron Python is the base installation for Python that Jupyter notebook uses. So when you see a IPYNB extensions, that means it's the Jupyter notebook. So if you can open the notebooks, hello Jupyter.ipynb, then we will follow the instructions there. All right. So I hope you have this opened up. It's basically this cell is a markdown cell. It is not an executable cell. So the way you can check and change is to go to the cell and cell type, where you can say whether this is going to be a code cell or a markdown cell. That's pretty much what we will use for most of the time. So the first one is obviously is a markdown cell. So where you can put in any commands or visualization or graphics that you would want to use in your analysis, and that goes there. And if you want to create a new code cell, you go here and you can change the code cell to code if it is already there, or you could use this plus button where it creates a new cell. So basically, if you keep clicking, it will keep throwing the new cells, and then you can go back and forth and you can change the cell type. By default, it creates the code cell where you can say like print hello world from Jupyter. So the way to execute this cell is that you can highlight the cell that you are in, and then you can click run. Then you get the immediate response on the output of this instruction, the code that you're using it in the cell. The fastest way to do it is that highlight this, the cell that you are in, use Shift Enter. That's faster because when you're running several commands at a time and you don't want to go back and forth, and there are many shortcuts that are available. You can go search on the web on Jupyter shortcuts, which will come very handy. I think it will be easy and makes things faster to use Jupyter notebook by learning this shortcuts. So you could create multiple cells. You keep clicking plus, or you can say another shortcut is like escape B will create the cell below, and escape A will create cell above. So those are some additional shortcuts. So you can use the tab completion, which is one of the nice feature in Jupyter Notebook that allows you to see what are the options that you have available, whether it is a function or the properties that are available for this particular object that you have created. So for example, you create a variable called hello world, and then you can use A and say tab, then you gives you all this function and the properties that are available for this object. In this case, A is a string object. For the string class, what are the functions, what are the methods that are available? So it's easy to scroll through them and whatever you would like to use them in terms of the code that you are writing. So that's the one big advantage. And how to get help in Jupyter Notebook? Again, use this question mark. So it gives you all the functions and methods available for this particular object, then all you have to use this is the question mark. And one of the things that we would pretty much care about when you're writing a most optimized programming code is that how much time each section of your code it takes, so that you can understand and optimize it for any performance issues, where we would use a time construct. The way to use a time construct is percentage and then times, then it automatically gives you the time it takes to execute. So in this case, it tells you what is the CPU time, and all the wait time and all those things it gives you in terms of the time it taken to run the command. Sometimes you might get into some issues where things are not working. If your kernel is stuck, all you can do is that go to kernel and then say restart, and that clears up any issues that you might run into.